We're now dealing with the empirical formula and molecular formula. Key thing to understand is the empirical formula is the simplest whole number ratio of the molecular formula, or the molecular formula is a multiple of the empirical formula. Same definition, just depends on where you're focusing on, empirical or molecular. And we talked about these ratios. But first, let's move on to calculating the empirical formula. First of all, what we're going to start out with is we've just finished calculating the percent composition. Now we're going to use those percent composition to work backwards and go back to the formula. So first of all, like we saw before, our percents add up to 100%. We're first going to assume that 100% equals 100 grams. So all we're going to do is change the percent sign to G. Then we're going to get from mass to moles using molar mass. We get that from the periodic table. Then we're going to get our lowest number of moles. So the lowest answer, we're going to divide through by that, and that's setting up our mole to mole ratio. And if needed, based upon our rules for very specific rule for rounding, if so, we may have to multiply through by a multiple. Here are the rules for rounding. Only do we use it here with the empirical formula, and it's the plus or minus 0.05 rule. So to get back to the nearest whole number, which I have to get back to, my answer has to be within a 0.05 range. Like the first one, divide through my lowest number of moles, and my y ends up being 1.03. Well, that's close enough to 1. If I have 1 in mind, divide through by lowest number of moles, and one of my answer comes up as a 0.5, then I'm going to multiply through by 2, and everyone's multiplied through by 2. If I have a 0.33, a 0.66, or a 0.67, then I'm going to multiply through by 3. That's going to bring me right within the 0.05 range of a whole number. And the last situation you'll deal with is if you're 0.25, a quarter, you just multiply through by 4. The first example of this empirical formula is I give you this, we'll say we go to a crime scene and a sample was picked up, and of this sample they know it's made up of 26.5% potassium, 35.4% chromium, and 38.0% oxygen. So what we're first going to do is we're going to assume those percents, 100% or 100 grams, we're just going to change the percent to a gram. But we know it's not a gram to gram to gram ratio, it's a mole to mole to mole, so we have to get from mass to moles. When we do that using molar mass. And when we get this, we know that 1 mole of potassium equals 39.10 grams. We get that from the periodic table. I put moles over grams for one reason, just my grams cancel out. I end up in moles. And I'm going to do that for my chromium, and I'm going to also do that for my oxygen. In this process, I get the moles of each one of them. Now, my lowest answer is 0.68. So I'm going to divide everyone back through by 0.68. That's my step 3. And so I see my chromium and my potassium and chromium both end up as 1, but my oxygen ends up as 3.5. Now I know in this formula I can't say KCrO 3.5, it has to be a whole number. So I'm going to multiply through by 2. So if I distribute through by 2, it's going to end up as K2Cr2O7, which was potassium dichromate. A second example, we now have samples made up of 52% zinc, 9.06% carbon, and 38.4% oxygen. I changed these first of all, assuming 100% equals 100 grams. I changed my percent to grams. Again, knowing that it's not a mass, it's not a gram to gram to gram ratio, it's a mole to mole to mole. Once again, we use molar mass. So I have 52 grams of zinc, and I want to change it to moles. So I look on the periodic table, and zinc weighs in at 65.39 grams. I put moles over grams for one reason only, so my grams cancel out. So I'm simply dividing, and I do that for my zinc, I do that for my carbon, and I do that for my oxygen. Now I get the least number of moles, which is 0.8, so I'm going to divide everyone back through by 0.8. And I do that, all of them are within a 0.05 range, so I keep them all as whole numbers. So I realize I have 1 zinc, 1 carbon, and 3 oxygens. I never have to show the ones are understood. So it's zinc carbonate.